Today we're going to demonstrate the functionality of our ALU that we built for Lab 6. So right now our operational code is set to 100, and which is the add functionality. So if we're not adding any bits, then both outputs are 0. And then y2 is the most significant, which is the carry, and y1 is the least significant. If we have either one of them being on, that means that we're only sending 1 into it. So only the least significant bit is 1. And then if we send both things, now we can see that the carry is 1 because we're carrying it to the next bit. And if all three lights up, then we have both the carry and the least significant bit, which is correct. So now for our next function, we're going to choose the NAND and AND. And y2 is going to be the NAND, and then y1 is AND. And right now we can see that because of the function, that both of them has to be the opposite of each other. So right now we're only considering A and B, and C is not in our equation. And then we can see that NAND, which is y2 here, is light up because both of them are off. So if both of them are on, then we can see that yes, we have y1 on. This is the same thing here because both of them are not 1. Our y1, which is AND, is off. And then y2, the opposite, is on. So then we go to our next function, which is we're going for the XOR and XNOR. We can see that XOR requires us to be explicitly to be the opposite of each other. So in this case, we can see that y1 lights up, and then y2 is off. Again, they're the opposite of each other. So if they're explicitly different, then XOR should be light up, which is correct. And if they're not, then y2 will light up. So if we go to the last function, which is OR and NOR, in y2 being the NOR and y1 being the OR, you can see that, let's say for the y1, that means either of them or both of them can be 1. So because right now both of them are 0, our NOR is on because none of them are 1, which is correct. And then for all the other cases, y1 should be on because y1 is the OR gate. So now we've demonstrated all 4 functionality, and we can see that they are performing as we expected.